Thank you, thank you. Yeah, it's been a long day. I had a lot of great conversations with a lot of people here. Some of you are in the audience, some have gone home for a good reason. But try to stick around until the end and the party and all that stuff. I hope we have a good magnification here. I think it's good. Uh, oh, yeah, yeah. You know, I'm old school. So that you will see me going like this, and my wife always makes fun of me because I look like an old person, which I am. Anyway, thanks for sticking around. We're going to talk about our new release, Lightning Studio. We launched it about 2 months ago, less than 2 months ago. We have a very long list of users that are jumping on the platform. Do we come from? Where does Lightning AI come from? Today during the workshop, I asked how many of you knew about PyTorch, PyTorch Lightning. You're a crowd of developers. So for good reason, you're using AI without using the tools that are used to build AI models. And this is great, I think, because it means the AI is getting into the developer community and allowing people to build systems out of whatever researchers have been building up until now. But PyTorch Lightning is a framework that is used, it was downloaded more than 90 million times. We have a large number of PyPy downloads. They're always increasing month over month. We're about 6 million downloads per month now. So it's used in very many organizations, used to train very large models. Stable Diffusion, who knows Stable Diffusion among you? The model that, draw me a monkey with on a ice skating monkey, whatever, and it produces images. This was trained using PyTorch Lightning, and many of the models that you see today are trained using PyTorch Lightning on many, many GPUs. But once these models are trained, then they become available to you to build stuff. And we have seen a lot of very good presentations about building agents, building systems with retrieval, and so on. This is all well and good, but do you have a good environment to do that? Do you have a good environment to build these systems? What would you use today? If you clone a GitHub repository, then you will run this code somewhere on a cloud instance, on your local machine, on a Docker container, and then you need to run that on a GPU, for example, and then you need another system to do the retrieval part that needs a small GPU maybe to be efficient. And so very easily you're facing the challenge of setting up cloud environments that can be complex, and they're the primary reason why you can't move fast. Having to do with all that complexity prevents you from moving fast. And moving fast nowadays is really, really important. So this is why we created Lightning Studio. Lightning Studio is like my laptop. It has the simplicity of my laptop. It's only compute and storage. I don't need to know any APIs. And as you can see here, there's an editor. I will play a little video here for you guys to just take a look at what this is. What we see here is a code editor. It's an IDE on the cloud. It's something that you can use to do many things, fine-tune, pre-train models on tens of GPUs, host web apps. And all it does is basically presents you with a development environment and lets you expose parts from that environment, or, I meant to go a bit slower. This is how a studio looks like. It is an IDE, but on the right you see all these icons here, and these are apps and plugins that you can use to interact with your cloud environment. One of the nice things about this environment is that, we fast forward a little bit, is that it can allow you to be in your environment and run the code on different instance types on different machines. So if you click on the icon that says for CPU here, you can then easily switch to an 810G, a A100, T-Force, and so you can run your same code now on GPU, and the switch is 10 seconds, 20 seconds, the time to provision the machine. And you get the whole machine, right? So first thing, you get your environment that you set up, your packages you installed, and the hardware detaches behind and reattaches new hardware, and your environment is preserved. This comes with an implication. We have environments that can be replicated, and so these replicated environments that can now be duplicated as well. So now you can go and let's go out of this video. You have no environment set up. You land on an environment that is pre-configured, or you configure it yourself. You can switch CPU, GPU very easily, but also you can duplicate studios. And I'm going to show you an example of that real quickly. Okay, so this is my studio. I'm going to run a studio, very big, bare bones studios. This is coming up. This is a whole machine that is provisioned to me, and it's running on a 4 CPU instance, which is the basic ones. This CPU instance is for free, so you can use it free to code in the cloud. You can also connect your VS Code, local VS Code, to this if you prefer, if you have it all configured for yourself. And you have code that you can run, no big deal here, right? And it's setting itself up. It will print hello world in a few seconds. Now, yeah. Now, what if I want to run this same code, or maybe some machine learning code that I can download from GitHub, like this one. So this is a model. This is an autoencoder that will train itself. And it will download data in a second and start training. This is a very small model, so it trains on a CPU. That's fine. What if I want to run it on a GPU now? Well, I just need to stop it and then start it on a GPU. And in a few seconds, this same code will be running on a GPU. Now, switching environment becomes really easy and cost-free. So I can code all my time on a CPU instance. When it's time to test it on a GPU, I can just switch the instance to that GPU. And this is going to come up in a few seconds again. And the switching will not enforce me to recreate the environment that I had before. Okay, so this is the switching. The switching happened. I'm already in the new environment. It's setting itself up. And the code that I wrote will pick up that it's running on a GPU. That's fine. So what's the next step for this? Well, I can also, this is a Rational Crimson studio. I can go to my list of studios, and I can now duplicate it. Great. So I create a duplication of my laptop that I had before that I attached a GPU on, and I create another laptop that is the clone of the first one. And this new laptop will run the exact same code as the previous one, right? So now I have something that I can create multiple copies of the same environment for myself. But I can also share with you, with people of my team, and they can start from where I left. The next implication of this, on whatever instance they want, of course. The next implication of this is that I can now create a set of studios that are pre-configured, and you can go to our gallery, for example, and using the same mechanism, I can publicly share my studio, which is the code, the checkpoints, the data that it comes with it. So now I have a way to publish the whole environment. It's not a repository. How many times, for example, have you gone onto a Git repo that had some machine learning stuff on it, tried to run it on your machine, you were missing dependencies, the drivers were not right, you had configuration problems. Well, with this, you can be guaranteed that whoever published this environment will be able to run it on their own, will be able to enable people to run it on their own environment, like cloud account. For example, we can check I want to run a mixture of expert model on a single latent G. I go here, I can read the about page for this studio. It can tell me useful things, and then I can just run it. This will duplicate whoever created this environment, this studio would let me duplicate it on my own infrastructure. Now I'm duplicating the studio on my own infra. What will come with this will be source code, checkpoints, all the model will be set up. I'm sure that the drivers will work, and I can have a conversation with my Mixtral mixture of X model, which is a very large model. It's currently one of the best, if not the best, open source model out there. We give it a second to set things up. Now the machine is there, and it will let me have a conversation as soon as the bar goes to the end. What I can do with this is also write, for example, a Streamlit application that serves this model. And here is like a 60-line Streamlit application with which I can create a rich experience for this model. Let's run it using the Streamlit plugin. It's one of the plugins we have. So I get a new app. I can point it to where the Streamlit application is, and I can just run it. Now, what this means is that I can now deliver an application to one of my customers, and I can let one of my customers duplicate the studio, or I can run the studio myself for our customers to consume. And we will see that the generation speed, even on a single latent G, thanks to the quantization that is present in what is running the studio, makes it really something you can build systems with. So now, suppose I want to build a RAG system. We've seen many examples of retrieval-augmented generation. One of the challenges is, where do I run, if I want to self-host the model, where do I run that model on? What infrastructure do I need to run it on? And then the retrieval part, where do I run it? So how do we make it easy to build a system that is now comprised of multiple machines interacting together? And so we can have this studio expose a port, a custom port, to the internet that I can protect using authentication, of course. And I can say, okay, just expose whatever server is running within this machine. And in this case, it's Olama, which is a very nice project to run local models on your machine, but in this case, it's in a studio. And then I can get this URL, which is the URL that will expose the API, and then go to another studio that switched off in the meantime. And use the endpoint exposed by the first studio as an input to the RAG pipeline that I will have here. In this case, I'm using the SPI, which is a very cool project, open source project by Stanford. But there are excellent ones, LangChain, Llama Index, beautiful, that we saw before. So I'm adding the base URL here for an Olama local model that will run and that will power my RAG pipeline. And yeah, this is all I need to make this system I will import the SPI. Yep, okay. Then I will configure the endpoints. One will be a public Colbert endpoint with the Wikipedia abstracts on it. And the other one will be my local Mistral studio that I'm exposing on the other side. And then I can load a data set that will let me optimize my prompts dynamically using the interaction between Colbert and the Mistral model. It takes about 20 seconds to load the data. "30 seconds to load the data. Hey, 40 seconds to load the data. Okay, 40 seconds to load the data. And this is the kind of data there is. There's a question, there is an answer, and I want the system to optimize my performance on the answers. And so I can build a chain of thought, RAG-powered chain of thought pipeline that will generate a search query given a context and a question, and then from the context and the retrieval, generate the answer. And they will do it multi-hop, so it will loop through the generate and retrieve and loop until it can generate the answer. So in 2 hops in this case. And then I can just let the optimizers that DSPy comes with generate a series of augmented prompts automatically so that the prompt will get more and more sophisticated based on the interaction that this object has with the mixed trial mixture of expert model that is running on the other studio. So as I demonstrated here, is this one or is probably this one? Yeah. And you can see the requests on the other studio spiking, right, on the GPU. So this to say that Studios is a very flexible tool, environment that you can use to not just train, fine-tune, build simple web apps off, but you can build systems. And system building is one of the challenges of building AI systems today. So we need pieces that can self-host model. You could call out into AI API like OpenAI and so on. So what I want to show you now is how you can connect your own cloud account here. So we talked about self-hosting models, but they were still running on our cloud account, the managed Lightning Cloud. If you want, you can connect a cloud account from an AWS account that you have, and all the compute and storage will run off your account. So we will be only orchestrating on behalf of you and will not get any data out unless you access it through the UI, in which case we will just proxy the data out. All right, so we have a bunch of studios that you can start using today. We have a public gallery of studios that show stuff like fine-tuning a language model on data, so taking a base model, instruction tune it, convert files for making training faster, run CodeLlama, the new model, build the RAG pipelines, fine-tune Hugging Face models, and build the full, RAG systems with it. So hopefully we, in the next few weeks, there's one last thing that I want to tell you. So in the next few weeks, we'll open up publishing for everyone. So this will mean that we not only will have a public gallery of studios that we publish or we and other collaborators publish, but you will be able to publish your own studios under your own personal account or your own organizations. This means that along with publishing a GitHub repo, if you want to share your work, you will be able to publish a full environment that will allow anyone to consume your own environment that it has been prepackaged by you. So there will be a very small gap between seeing something like this and being able to run it on my own infrastructure. So anything you've seen today from the previous presentations that is in the open source or APIs, private APIs, you will be able to consume from within studios just by duplicating the studios. And for example, you can go from simple applications to full-blown pre-training LLMs, like in this case where we pre-trained Tiny Llama 1.1 billion over 3 trillion tokens, over 64 GPUs. And these are the numbers that we obtain, very good machine flop utilization. So we can go from small applications to full-blown pre-training. All right, so if there are questions, otherwise, I hope you guys sign up for studios. We have documentation on Studio that is landing, is not there yet, but you can reach out to us on our Discord. You're more than happy to join us, and I hope you will find the tool useful for your work. Thank you.